大家好，欢迎来到今天 R0最后一场今天的压轴议程。那这场我们请到日本一个知名的数位鉴识的团体，Yamato Lab Community 这个团体，然后他们今天会在HackerCon 发表最新版的开放原始码的数位鉴识还有 threat hunting 工具。那这边有好几个工具。他们有的工具我之前用过，就是像是分析电脑上的 timeline， 分析 event log， 分析各种东西。那3位讲师呢都有非常重要的来历。Zach Mathis 是很有名，也是我很久的朋友，他是Kobe Digital Lab 的 CTO， 然后也是这个 community 的创办人。然后这2位是Nishikawa 桑和 Takajo 桑。他们也分别是这个 Open Source 计划的contributor。那今天非常感谢他们愿意3个人一起飞来台湾，而且一次要发表4个资安threat hunting工具的最新版本，会立刻 Open Source 给大家用。让我们用热烈的掌声欢迎他们。
Thank you for that introduction, and thank you all for coming. We're very excited to be here. Taiwan is one of our favorite countries, and HitCon is one of our favorite security conferences. So congratulations on 20 years. Just a brief self-introduction before we get started. My name is Zach Mathis. I am the founder of Yamato Security and kind of the project leader for all of the different projects that we provide. I'm originally from the US and spent about 20 years there, and then for the past 20 years I've been living in Japan, doing about half offensive type security and half defense security for a company called KDL, as well as I have my own company, and I also teach for SANS.
Hi, my name is Akira Nishikawa. I was the first main developer for Hayabusa. I currently work at Kaminashi doing SaaS product security.
Hi, my name is Fukusuke Takahashi. I'm a recent core developer for Hayabusa and Takajo. In daily work at NTT Data Cert, I do DFIR and OSINT and SOAR. Thank you.
So this is the agenda for our talk. So I'll talk about our tools and resources. Then Takashi-san will talk about how to use our tools with another open source and free tool called Velociraptor in order to make it scalable. So instead of just doing investigations on one endpoint, you can do it on virtually an infinite amount of workstations in any large-scale environment. Then Nishikawa-san will talk about a new feature that he's created in Takajo for visualizing all of the different results in Hayabusa. And then we've received a request to talk about how we manage our open source tools and have such active development. And I think maybe since we have such a large amount of young students here are also kind of looking forward to trying to do something similar. We hope we can provide some advice. And then lastly, I'll talk about our future plans. So the first thing, Yamato Security's tools and resources. We have various different projects, but probably our two flagship projects are Hayabusa and Takajo, which I'll explain about more in detail. Just kind of curious, has anybody used any of our tools before, Hayabusa or Takajo or anything? All right, a couple of people, thanks very much. So as I mentioned, we have a couple here. Hayabusa is a DFIR timeline generator using Sigma rules for Windows event logs. So it's mainly a tool for investigating Windows endpoints, which in most incident response, Windows is the dominant OS, so we put our focus here now, but in the future, we hope to create other tools for Mac, Linux, cloud, and things like this, and do some kind of similar things. And then we have Takajo, which will take that analysis even further and try to make things even easier. So we try to automate as much as possible what analysts would do after they created like a Hayabusa timeline. We also have an event log configuration guide for DFIR and threat hunting. And then our last probably project that we're really focusing on these days is the curation of Sigma rules in order to make them easier to use, and not just from an analyst perspective, but also from like a tool developer's perspective. So here's just a quick kind of outline of Hayabusa. If any of you have done incident response with Windows event logs, and you try to do it with using the built-in event viewer, I'm sure you probably didn't have the greatest amount of time. Windows event logs, they're separated into hundreds of different logs, and in our experience, about 80 to 90% is just noise. So it's trying to find the needles in a haystack, and it's a very difficult process. So what Hayabusa will do is it will use these Sigma rules to find all of the different needles for you, and it just creates a timeline, either in CSV or JSON, of just all of the different important events that you want to, or you care about for your investigation. So as you can see here on the right, Hayabusa has many different commands. It can do login summaries, take different kinds of metrics, keyword searches, extracting out keywords that you can pivot on, etc. But probably the main reason people use Hayabusa is for utilizing those Sigma rules and then outputting to a CSV timeline or a JSON timeline and then analyzing that timeline. So I'm guessing by now, many of you, especially if you are into detection engineering, have already heard of Sigma, but just in case, for those of you who haven't, Sigma is another open source project, and it's a free and open source detection rules for all sorts of platforms. So it's not just Windows event logs. They have it for cloud platforms, Linux, Mac, firewalls, any kind of appliance you can think of. But they probably have the most rules for Windows event logs. So this is the most well supported, and now we have over 4,000 different detection rules that can detect on all sorts of different attacks that you see in Active Directory environments. The advantage of using Sigma detection rules when you're doing threat hunting or fast forensics is that, first, it's very easy to write and to read because it's just YAML files. So you don't have to do any complex KQL queries or Splunk queries or things like that. The second benefit is that it's all free, very high quality detection rules, and often the security researchers out there will release Sigma rules before many of the main product vendors out there. So you are getting kind of the latest and greatest detections with Sigma rules. And then the third great thing about Sigma is that it is now kind of the universal format for detecting log sources. So you can convert any Sigma YAML rule into any other kind of back-end SIEM that you can think of. So Splunk, Elasticstack, QRadar, KQL, C#, PowerShell, anything you can think of, you can convert it. So now you're not locked into a single vendor. So if you were, say, using Splunk and you wrote all of your detection rules in Splunk, but then you realize that you want to save some money, maybe switch over to Elasticstack, it's going to be a very painful process because now you have to rewrite, thousands of different rules, where if you just write the detection rules in Sigma, then now it doesn't matter what backend that you're using. So here's just a quick kind of overview at the high layers. So we have on the left, you input the .evtx Windows event logs into Hayabusa. Hayabusa will use the thousands of Sigma rules, output either a CSV file or a JSON file, and then you can load that CSV file into something like Timeline Explorer or even Excel. You can analyze JSON, doing some more kind of advanced parsing with the JQ tool on the command line. You can import it into Splunk or Elasticstack or any of these kind of SIEMs if you want to do threat hunting there. And you can also send the JSON file to Takajo, which we'll talk about later, which will then further automate a lot of the different analysis process for you. It'll create different CSV timelines for things like logins, suspicious processes. You can visualize out the TTPs according to the MITRE ATT&CK framework, and much more. So Hayabusa we started about 3.5 years ago, and we've had almost about 45 different major updates. So we have major updates almost every month for about 3 years. As you can see, lots of commits, lots of issues closed, pull requests merged, so it's a very active project, and we're very happy that many people around the world, many CERT teams in all the different countries around the world, and all the different security vendors are using this tool, so we're very happy that others are getting use out of this. Today, we have a special HitCon release, so I just released the new version 2.17.0. So it turns on this, what we call the low memory mode, which doesn't sort the events. So now you can scan hundreds of gigabytes or terabytes of event logs with less than 4 gigabytes of memory. It has better support for sigma correlation rules and other enhancements. So if you're interested in all of the new features, just check the changelog. And this is all thanks to Fukusuke Takashi-san here and another core member, Dustin Dark. So Takajo, we'll talk about a little later as well, but this is kind of a companion tool to Hayabusa, and it is written in NIM. How many here have heard of NIM before? It's 1 person, 2 persons, thank you. It's still kind of a minor language, but personally, I really like this because NIM is basically a type of, it looks like a type of scripting language like PowerShell or Python. However, it gets compiled into C code, so you get standalone binaries that are as fast as C or Rust. And you don't have to worry about anti-forensics techniques and buffer overflows and memory corruption and things like that. So if you wanted to try to extend Takajo, even if you're not the best programmer out there, and you can't do something as difficult like Rust, which is what Hayabusa uses, you should be able to pick up NIM pretty quickly. So later, Nishikawa-san will talk about the HTML report, which will help visualize things, but as I mentioned, it will automate a lot of the things, like it'll extract out all of the different PowerShell logs, which get fragmented in many different event logs. You can pull out IP addresses, hashes, you can do virus total lookups, etc. The main problems with Windows event log analysis is that during kind of the preparation phase of IR, you really need to turn on and enable a lot of the different audit settings. So unfortunately, the default settings, not just in Windows, but in almost every operating system, is very poor. And if you just have the default settings on, if you have an incident, a lot of the times, because you don't have the very important process creation logs, you don't know if malware was executed, what that malware did, etc. So there are various log configuration guides out there that you should still check out. Ones from NSA, the one from the Australian government is kind of my favorite. And then I based my research kind of from the one from the Australian government and tuned it a little bit. And I checked the log settings based on these real-world Sigma detections. So if you just have detection logs, or detection rules, but you don't have the logs, of course you're not going to be able to detect anything. And if you just have the logs but no detection rules, also you're not going to be able to detect anything. So you need both of those. And what kind of the research and the write-up that we did, it'll show you what log audit settings you need to turn on, enable to detect all these various different attacks. So it'll tell you in very much detailed about if you enable this setting, you can now detect attacks like DC Sync or Kerberos or things like that. So if you're interested and you do IR on Windows, please check out this documentation. We also include a batch script to automate this as well, and I'll probably update it to something like a more advanced PowerShell script. So as you can see here, if you just have the default settings on Windows, you can only utilize about 10 to 15% of the Sigma detection rules out there. So you can still, of course, detect some attacks, but you're still going to miss a majority of the different attacks. If you enabled all of the different audit settings properly, you can now utilize up to 75% of Sigma rules, which will give you much better detection coverage. And if you wanted 100%, you would need to install a sysmon agent to get that remaining at 25% of Sigma rules. So here's just a quick top list of the different Sigma rules out there, and it tells you if they're looking at logs that are enabled by default or not. And as we can see, the one at the very top, process creation, consists of about half of the Sigma rules out there. It's the most important, and you need either sysmon event ID 1 or security 4688 enabled in order to get that. And you can see the other categories are also very important, but the majority is all in red, meaning that you would need to install sysmon or enable proper logging. So the next one, project that we also just released a major update on the documentation is about how we curate our Sigma rules. So Hayabusa won't just use the upstream Sigma rules as is. It will de-abstract out the log source field, which I'll give an example in the next slide. So for those of you who are familiar with Sigma, in Sigma rules, you don't specify the log channel and event IDs. You specify different categories, such as process creation, and then the back end needs to figure out how to convert that and filter in just on, say, the channel security, event ID 4688, etc. So process creation is probably the most famous case for this, but also registry events, network events, and we're also looking into being able to use Sigma for detecting built-in WMI attacks as well, using the built-in logs. And what you would need to do is have a backend that knows how to properly parse this log source field and change all of the different field values. So I'll show you an example, as it'll probably be easier than me trying to just explain this orally. At the top, we have the original Sigma rule, and you can see it's looking for a selection where the image field ends with .exe, and the category is process creation. So this is original upstream rule. If it was just this, and your Sigma native tool, native parsing tool did not understand how to handle the log source field, then you would get very many false positives because it's not doing any filtering on the channel or event ID. So what we do is we've created a tool that will convert the Sigma original rule at the top into two different rules, one for sysmon and one for the built-in event. So what we do is we add a condition here on the left with the sysmon rule, and we create a new condition called process creation. We put in that channel name and event ID, and then we update the condition. For the built-in event rule, we do the same thing, add the channel and event ID condition, but the field names are different between logs. So we would also have to convert the image field name to this on the right to new process name. So if it was only a matter of adding the channel and event ID and changing some field names, it's not so complex. You could probably have a backend handle this. However, the problem is, it's not just a matter of changing the field names, you also sometimes need to change the value as well. So for example, on the left, the sysmon puts its process ID as like 7772, just as a standard integer, but in the built-in process ID field, it shows it as hex for whatever reason. So there's no really consistency between Windows event logs, and a lot of these fields are incompatible with each other. So if you're creating detection rules that are relying on these field names in the red that don't exist in the other log, then you're not going to be able to create one Sigma rule that can detect both types of logs. So I don't think anybody has really looked into the differences between the sysmon and the built-in logs to this degree. So we've been spending some time, not just for process creation, but for the network connections, which is also a very important log. And then I'm also going to update the documentation later for registry events and for WMI events as well. So this is something very important for detection engineers who are writing Sigma rules to understand the different characteristics between these logs, and ideally create detection rules that can handle both types of logs, because in many environments, the company doesn't want to install sysmon agents on every Windows endpoint because they have to maintain that. If you don't configure sysmon correctly, you may slow down the Windows machine, you may cause blue screens of death and things like that, and you have to constantly update it. And so when I talk to clients and I tell them, to get the best visibility, you should install sysmon, they understand, but they don't have the resources to properly maintain it. So in that case, that's unfortunate, but what you can do is if you can't install sysmon on everything, you can turn on all these built-in logs, and then hopefully if you can utilize the Sigma rules to detect the built-in logs, then you're going to have a much easier time in the investigation. So here's just a summary of why we de-abstract that log source field. You can detect built-in Windows events with the default logs. It's easier to read and understand the rule because all of the field names and values are exactly how they are in the logs. And it's easier for native Sigma parsers to use. So if you're interested in what I just talked about, there's a long documentation. And if you just want to use the rules because they're easier to use than the upstream Sigma rules, we have the Hayabusa rules repository that you can just download and use that. And Hayabusa and now Velociraptor also uses these curated rules instead of the upstream rules. So now we'll have Takashi-san talk about Velociraptor.
Now I will talk about how to perform a scalable DFIR using Hayabusa and Velociraptor. While most major organizations have EDR and SIEM operations set up, the majority of organizations, small to medium businesses in particular, may not have the resources to properly implement these security measures. Even in larger organizations, it is rare to find EDR installed with 100% coverage, as well as a coverage for logs sent to the SIEM. We also rarely to see organizations with proper log audit settings, which causes a big problem when the machine gets hacked. And we need to investigate, but can't tell exactly what happened because the logs were not recorded. So one way to fix this problem when incident responders are in this situation is by temporarily deploying Velociraptor agents to Windows endpoints and running Hayabusa to scan Windows event logs, detect the majority of attacks, and just send back the useful information, essentially recreating a SIEM with only important information. The information can then be further run through a tool called Takajo, which we will explain later, in order to make investigation even easier. Then, how many people know about or use Velociraptor? Please raise your hand. Thank you so much. It is a free open source tool now maintained by Rapid7. It creates a type of C2 server for Blue Team members, and the agent that you push out to endpoints will connect back to it. You then send VQL or Velociraptor query language SQL-like queries over to gather any foreign artifacts you can think of, like prefetch, timestamps, SIEM caps, MFT, general information, or even those event logs, etc. You can set up Velociraptor in 3 easy steps. First, you start the Velociraptor web GUI with the Velociraptor GUI command. Second, you create MSI packages to install on the endpoints you want to investigate. Lastly, you just need to use sorry, thank you so much. Sorry. You just need to use a central management tool like group policy or Intune, etc., to distribute Velociraptor agents. Here is a screenshot of the Velociraptor server's web GUI. There is one Windows 11 client machine called Mouse that has connected to the server. Now, the analysts just send different VQL queries to the client and collect their information. In this example, we are selecting Windows event logs and using regular expressions to extract out IP address from the RDP event. If you want to get out of the useful logs for investigation, then we would recommend using Hayabusa. It is not part of the built-in VQL queries, so you first need to download the artifact, and we provide in the third-party community exchange. You can do this easily by running server import artifact exchange to import the community VQL artifacts, then run the Hayabusa artifacts. The results from Hayabusa are shown here in the GUI, but we recommend to download the CSV or JSON and import them into tools like Timeline Explorer or Elasticsearch or Splunk, etc. So now that we have pushed out Velociraptor agents to all the Windows endpoints, run Hayabusa and collected the result, we now need to analyze the result. If there are many endpoints, this will be a very long manual process So it is better to try to analyze the result all at once.
In order to analyze all the results at once and automate much of the analysis process, I recommend to use Takajo, which I will now explain about. As you might know, Hayabusa means Falcon and Takajo means Falconer. So Takajo will further automate the analysis for you. As shown in the screenshot, you can easily collect Hayabusa JSON-L results from many clients using Velociraptor. Through the web GUI, you can also download the results from multiple clients in one file. Takajo may be difficult to use at first because it has so many commands. The good thing is you only need to remember one command that will automate everything for you, AutoMagic. After downloading the JSON-L file, you just need to run the simple AutoMagic command as shown here. This is a screenshot of the summary of all commands run. One of them is visualizing the TTPs of the attacks to give you a high-level view. Here is an example of a stack analysis that let you quickly find outliers. This was explained earlier as well, but here is a list of all of the commands that AutoMagic will run for you. We have a brand new command for the 2.6 HitCon community release today. This will let you perform triage in a graphical manner. We output an HTML report, so it is for you and your teammates to analyze at the same time. We create an SQLite file, so lookups are fast, and you can also investigate the raw data with SQL queries. The detections are visualized by data, so it is easy to determine when an incident may have happened. Here is the format of the simple HTML report command. You just need to specify the output file name, timeline JSON file, and Sigma rules path. This is the index page. You can see we have a summary of the detection results. At the bottom shows data with most total detections. You can see the number of the different severity levels based on the date, so it is easy to guess when an incident has happened. The sidebar is closed at first, but if you click on the arrows next to the alerts, you can get a listing of the different detection rules that have hit. This screenshot is showing the alerts that you can see in the sidebar. You can see the names of all of the computers that had hits for certain rules. In this example, the computer mouse. Informational alerts are not included because they take up too much space. There is a general summary on the right-hand side. Here is a summary for the mouse computer. You can see the number of alerts at the top, followed by a graphical timeline when the different alerts happen. As you can see, we have too many low alerts that are getting in the way. So we can't see the other alerts for the other dates properly. If this happens, you can easily fix it by removing the low alerts results. By just clicking the severity levels, you can hide alerts such as the low alerts in this example. By By narrowing down non-critical and high alerts, you can easily determine the dates that an incident happened. In this example, October 21st, 2023 had the most critical alerts. So if this was a rare investigation, you would probably want to focus on the logs for that day. Underneath the graph, there is a list of alerts so you can guess what types of the attacks have occurred. If you click on one of the rules, it will show the sigma rule that caused the detection. Right now, this HTML report is great for smaller investigations, but may start to slow down or be overwhelmed with information for large incidents. In order to handle that, I am planning on creating a web server that dynamically pulls data from the index SQLite file through an API. Since only the requested data is being accessed at a time, this will allow better scalability. For example, you will be able to just show data for particular time frames. Like show me the data for just this date or for the past 30 days, etc.
All right, so I have only 5 minutes left. So I'll do a quick kind of advice for if anybody's interested into creating their own kind of open source tools. So if you are planning on creating an open source and free tool, please do, especially if it's for the blue team, because there's lots of red team tools out there, too many C2 frameworks, and defenders need more tools as well. If you are wondering what to create, I would first recommend to create something that will solve a problem that you currently have at your work. So even if the tool doesn't become, extremely popular, you're still going to be able to help yourself. If you don't know what to make, then start off by learning how to use GitHub, how to create issues, pull requests, and things like that, and then contribute to the different open source projects that are out there. So this is exactly what Takashi-san did at first. He was fixing bugs in Hayabusa, and we realized that he could really help us out. So that's how he first got in contact, and now he's one of our core developers. It doesn't have to be a tool. So if you're not a programmer, you can contribute to the community just by creating different documentation on anything you research. I would recommend to manage this on GitHub though, because more people will notice your project. It's easier to collaborate, and then you have that version control for every time you update it. So these projects are a lot of hard work, but they've been very well worth it for us. Other advice is make sure that if you're working as a team that you have a leader that you can trust, or to be that leader, have clear goals. For example, we started out Hayabusa by me just tweeting on Twitter, like I want to create a Windows event log analyzer because I was having problems in my IR work, and I didn't want to use tools like Event Viewer and things like that. So I said, let's create this tool and we can present it at a conference. And then I got back requests from about 40 to 50 people, and then that's kind of where the project started. We're very lucky in that we have a very diverse team, and I would highly recommend this because not one person can do everything. So we have members that are really good at programming, we have other members that are good at documentation, at presenting, design, and things like that. So you really need a diverse set of members that can collaborate and put together all of their strengths. I would recommend if you're doing it with a project, 3 to 5 people is probably the best. If you only have 1 or 2 people, then if 1 person or 2 people quit, then your project is dead. If you have more than 5 people, then it's hard to manage people. Also, have good documentation is something I would recommend. a lot of open source tools out there, they may be doing something really good, but a lot of the documentation isn't that great. So that's one of the reasons why a lot of the open source projects, don't continue on. Lastly, this is all volunteer work, so we don't force anybody to work. Some people come on, they'll work for a couple months or a year, then they might get busy with work or personal things, and then if we have other people to continue the project, then they usually come back. One other thing is to never give up. So when we first started Hayabusa and told everybody about it, we didn't get a big response, and it wasn't until about a year or so until people started really paying attention and realizing how easy this tool makes your work. So if you don't get the response that you're looking for at first, don't give up, just continue to improve. So try to aim for this, be so good that people can't ignore you. We do periodic meetings over Zoom. At first, we did it weekly. Now we do it every 2 or 3 weeks. We try to make it fun. If you've never met up in person, so at first, we just met online for half the people, and then we met up in person. Also makes things much easier to work with if you know the person and if you know the person in person. If someone contributes, make sure to thank them and always welcome more members. So our future plans, we hope to incorporate the big buzzword floating around AI. Eventually, in 2-3 years, it would be nice to have AI all locally. Just say, write a 10-page forensics report based on this Hayabusa data, and you get this 10-page forensics report that you can just look over. But this will probably take another 2-3 years. There are some challenges with this. And we would also like to implement some machine learning to do some kind of UEBA type detections for finding outliers, abnormal logins, and things like that. And we have a new tool that we're probably going to come out with next year called Suzaku, which does the same thing as Hayabusa, but for cloud logs. So if anybody is interested in this, I think a lot of people in Taiwan are very good with AI and machine learning. We would love to have collaboration with some Taiwanese people. Here's our GitHub link. Give us a star if you want to support us. You can follow us on the Twitters and things like that. And thank you very much for your time. Sorry, went a little bit over. Do we have time for
No
questions?
problem, no problem. Yeah. So this is a really, really great tool. I think that's the best open source forensic tool I have ever tried. And anyone, any questions? Okay, can you use a mic? 你可以用麦克风前面那个按下，对。
What kind of benefit do you envisage for integrating AI into your whole pipeline? Thanks.
What's the benefit of integrating AI into Hayabusa?
Into the whole pipeline.
Into the pipeline?
Yeah.
We'll just make things easier. So we're trying to make things as easy as possible, automate everything as possible. Of course, it's not going to be perfectly accurate, especially at first, but I believe it'll improve over time. So things like finding abnormal logins, those sort of kind of areas where you do need machine learning and more kind of high, more advanced mathematical statistics that we're not doing. We're trying to kind of see where we can go in those areas. I hope that answers your question. Is that okay?
Yeah.
All right, thanks. Yeah, and if anybody has any other questions later, we're going to be around here, so you can come up and talk to us one-on-one.
Okay, then 让我们再次用热烈的掌声谢谢他们。Thank you so much.